Okay, so he's given us these equations, and I don't really think that he knows what he's talking about. I've in the last part of this video, I kind of talked about what was going on there, what I think is going on, what I think he's talking about. But I'm gonna give him the benefit of the doubt. All right, let's say that what he's talking about is legit, and I'm less informed than I should be about this subject. Um, so let's use his equations to produce something. I don't know what it'll. I know the general idea what it'll be, but let's graph it to see what happens. Okay. And that was actually the thing that we're gonna make. But I put together these formula, and this is MATLAB, by the way. So it's basically a mathematical tool that we use to represent equations and matrices in an easy way. So if I wanted to make a number line from 1 to 10, I'd say x equals 1 to 10. Okay, that gives me the numbers 1 through 10, and then if I say y equals sine of x, that'll give me whatever sine of that value is. And if I plot x versus y, then it'll give me this broken sine function. Okay, that's fine. And it's broken because there's not very much resolution. If I increase the resolution by making more points here, let's say 1,000 points, and let's go steps by 0.001, then the resolution will get a lot better, and it'll be a lot more like a sine function. So let's go up to plot, and there's your resolution. Very smooth curve now that I gave it some data points. So anyway, that's the idea. So let's go over here. Now in his equation, his equations, he said that one was the convergent wave and the other was a divergent wave. Let's say that he didn't get so much sleep and he was confusing that with what I understand to be constructive and destructive interference. I'll give him the benefit of the doubt there. Let's say that what I'm talking about and what he's talking about are using different words for the same thing. Okay, fine. So what we have here, m is a constant. It shouldn't be because it's cubed. A is a constant. That's okay. That's fine. That's fine the way it is. Sometimes you need to define something. I don't know why there's a square root inside of a cosine, and I have no clue where you got 0.77 from to be an exponent of a cosine function. But you know what? It is. Ultimately, this is just a scalar that makes the amplitude of this lower, but that doesn't matter because it's a 0.77 in the exponent, so it makes it a little bit more complicated. Anyway, so we've got some constants defined here, and I've defined the radius here. Now, radius cannot be negative because it's the radius. Let's go over to this guy. If the radius was negative, it'd be inside of the middle here, and that just doesn't make any sense. Radius has to be positive. So I've defined the radius as from 0 to about 1,000, and that should be all we need because what we're going to end up producing is a sinh curve or a hyperbolic function, and those kind of taper off at the end. Okay, so we've got a divergent wave. I don't know what that means, but I think it means deconstructively interfering, which doesn't make sense because you've only got one-dimensionally dependent equation here. And I'm just going to trust me on my syntax here. There's some parentheses and whatever that make it hard to read, but basically this is a function that produces this guy, and I forgot some dots.
I put this up primarily.
That ought to do it. Okay. Okay, so we've got these two things, and if I were to plop those in there into MATLAB, I'll just run it. Then I ought to get some stuff. Cool, that's some stuff. Now R, so if I plot R versus convergent wave, I ought to get whatever this guy is. All right. So let's zoom in there because we can't see anything else unless we zoom in because I made the resolution too big. So anyway, yeah, you get a hyperbolic looking function here, and yeah, that's what a wave looks like when it dissipates. Like if you drop a penny in the pool, then it produces something like this. Sure, that makes sense. But you can also get this kind of equation right off of the Wikipedia page, and it doesn't necessarily fit the thing that he's talking about. I mean, I get it, but how is this revolutionary? This came straight off of a Wikipedia page. All right, well, let's say that he's got something in the other ones, you know. So let's plot R versus the divergent wave. It's going to be the same damn thing, just a little bit different because he added 3 instead of 20 to it. So let's go back over here. What's the difference between this equation and this equation? 2 things, exactly 2 things. Number 1, the constant inside the square root is different, and there's he adds 20 instead of 3. Okay, so what's going to change here is the amplitude of this function is going to be a little bit different, and it's going to be offset up a little bit. So if I add 20 to this equation, it's going to go up a little bit. The whole thing is going to go up. And if I change the b inside of this equation, then the whole amplitude will change a little bit. Ultimately, these aren't new things. David should know about this by now. David is my 14-year-old brother. He is in 8th grade, I think, and he should be learning about cosines by now. These aren't new ideas. So ultimately, let's give him the most benefit of the doubt that we can. Let's say that he does know what he's talking about. These equations are still irrelevant to what he's talking about. We have no extra information from these equations, and he's said verbatim that these are approximations of something that he helped derive. And I just can't buy into that because they were derived in 1700. Anyway, so let's just give him one more chance here. Let's say that adding these 2 things makes it somehow magical. So let's plot R versus together wave. And oh, by the way, there's some imaginary parts of the complex X that are ignored here because R is defined strangely. Anyway, go over to figure 1. And guess what? It's the same damn thing. Because all he did was add something over here. There's nothing significant except for these little blips. Maybe they are significant. There might be some constructive interference here, but ultimately, this seems like a random thing that was just thrown together by something that doesn't know what they're talking about. Anyway, so my 4 main points on why I don't think these equations are legitimate at all is because, number 1, he distances himself from knowledge when he says that, you know, I did this, I did that, and then right after he says I did this and I did that, he said that these equations are for people of that bend. And that means that he's not of that bend.
DVD elsewhere who
let me see if I can find
a green and a red. How the divergent I'm saying? All right. Now, I'll pause on this for about 10 seconds. Okay. This equation here is the one I use to generate what you're going to see in a minute.
What I use to generate what you see in a minute.
There's a yellow, a green, and a red equation, and these are the constants I plugged into those.
Constants I plugged into those. Again, this is high school vocabulary.
To show you how the divergent wave and the convergent wave add
again, divergent, convergent wave. This doesn't make sense.
Together to give you the yellow thing. Now,
he says yellow thing. It just it doesn't compute. Yellow thing is not a mathematical term.
Put this up primarily for the people who are going to see this DVD elsewhere.
He put this up primarily for the people who are going to see this elsewhere.
Or who are of that bend.
Who are of that bend. Okay, so the first thing he does is said, I did this, I did that. And the second thing he does is says, for people who are of that bend. Now, if I were up there, I would say, for people who are interested. This doesn't disclude me. And when I say that people are interested, I mean, I might be excluding people who aren't interested. That's fine. That makes them feel welcome. That's okay. But if I say for people of that bend, that's just strange to me because it distances the speaker from the people who would be interested in it. And he should be interested in it because he's speaking about it.
To show that this is the first approximation of the...
First approximation. was this the first approximation when it was coming, or was it the first